Hey folks, if we were meeting today in person, it would be the 11th. Yeah, it would be. It would be the 11th. And today, if you look at the topics for today, only have two things. That's it. Oh, nice, easy class. Piece of cake, nice, easy class, right? Well, maybe. Those two topics, though, say calculations. Did you read those? Calculations of kinetic friction, calculations of coefficients. We are now going to dive into doing calculations for our force problems. And these do get a little more complicated, but I will certainly want you to know how to do these. Trust me, you. Okay? All right. Now, you have in Essential Documents, a document that looks like this. It says force problems. Go find it. It's alphabetical. Force problems. I am not going to do the first 1, 2, 3, 4. Somebody just lied already. Not going to do the first two. Not going to do those. Nope. Not going to do them. Because they're relatively easy, and I've gone over problems like that. I will, however, you can go find force problems in the answers. The key is right below it in the Essential Documents, so you can go and do them yourself and see how you do. But I will go through how to do the 3, 4, 5, 6, and 7. Let's dive in. Force calculations with friction. All right, so I'll start with problem 3 on the force problems. Problem 3 says, a force of 300 newtons is applied to a 25 kilogram box on a nice horizontal table. Box on table. Love box on table. So let's do it. Box on horizontal table. Okay? All right. 25 kilograms, 300 newtons is applied to the box. So we're putting 300 newtons of force to a 25 kilogram box. Okay, the coefficient of friction. Oh, here we go. The coefficient of friction. Remember, the mu value is 0.3. 0.3. So mu is 0.30. Most things, everyday things that we slide things and move on, like our feet on the floor, somewhere between 0.25 and 0.35 is the coefficient of those frictions, like the rubber sole of my shoe and the linoleum floor. That's about 0.35. So this is a very common coefficient of friction, 0.3. All right, so here we have the box on table. We're going to push it along. And what do we want to do? What's the acceleration of the box? All right, here we go. Dive in. So now we have, I did it again. Did you notice? Did you? Before I point, I erased my equation again. It's just a habit. All right, you're out of the way. I'll put it here. F net equals Fm. I'm going to put that F move minus Fb back equals Ma. Okay, we need that. Force making this move, 300 newtons. Right there, 300 newtons. Force holding it back. Well, what's going to hold the box back? Friction. Friction. How do you know there's friction? How do you know? Because there was a coefficient of friction. The coefficient of friction was given as 0.30. Therefore, there must be friction. So friction is going to hold this back. Friction is dissipated. Friction says, no, you should not pass. Again, Gandalf. So friction is going to say no. Now, we don't know what that friction is. We have to calculate it. Once I've got that friction calculated, I'll put that right here in the force back, FB, and I'll set that equal to MA. Mass is 25. A is what we're trying to solve for. Okay, let's do it. Let's figure out the force of friction. I need my force of friction equation. FF equals Fn times mu. Okay, force of friction equals Fn. Fn is the normal force. Remember? Perpendicular force from the surface of the table down. And that's weight on a horizontal surface. Okay, weight. That's the weight. So this is the force of weight. So you have W equal times mu. The force of weight is equal to, remember, mg mu. There's my equation. There's my working equation, as I like to say. So F sub F equals mass 25 times little g, 9.8, times mu, which was 0.3. Calculate that out, and you will have the force of friction. So let's do it. Do it. 25 times 9.8 times 0.3. Boom. 73.5. 73.5 newtons. So that is the hold it back force. So I'll go ahead and put that up here. 73.5. And now I'm ready to solve for A. That's going to be 300 minus 73.5. Okay. Get 226.5 and divide by 25. So divide by 25. And we get 9.06 meters per second squared. So 9.06 meters per second squared. That's the answer for problem 3. Relatively straightforward problem. Now you might say, well, harder than the problems you were doing before with box on table. Yes, only because we had to calculate the friction. I didn't give it to you this time like I did in those problems early. You have to calculate it. And I would expect you to be able to do that. All right, leave you up there. Stop erasing it. Okay, ready. Problem 4. You pull a box with a constant, oh, I like this one. You pull a box with a constant velocity. That's key. Huge, huge 2 words. Constant velocity. What does that mean? That means it's not accelerating. Oh, it's moving, but it's not accelerating. Well, then there's no forces involved. Of course there are. If there were any forces involved, then the friction would slow it down, stop it. The force involved in moving it. So the force of moving it is equal to the force of friction. And that is a huge concept in physics. When you've got to remember that. If something's moving at a constant velocity, there's balance in the force, Luke. That means there's no acceleration. Constant velocity is no acceleration. No acceleration means these 2 things have balanced each other out, giving you a big fat 0 for your net force, and you have no acceleration. Oh, there's forces. They just balance. Constant velocity. I think of it this way. You're driving down the road in cruise control. All right, you're in Tom Cruise control. All right, no, he's a weirdo. Like, he's a good actor. I got to give him that. He's a little weird. So anyway, cruise control. Cruise control. What does that mean? It means you're going the same velocity. You're not accelerating. You're moving at a constant velocity. Wow, there's no forces involved. Of course there are. You know there are. The engine is applying a force to the tires to move you forward. And then there's friction. Friction between the road, air resistance, okay? Yeah, and those friction forces are balancing the engine force moving forward. The balance allows you to move at a constant velocity. The forces are equal. That's a huge concept. So you see those 2 words, constant velocity. Bells and whistles should be going off in your head. Okay, so what's the problem? Get back to the problem, please. The coefficient of friction is 0.6. Okay, let's put that here. Okay. Between the box and the surface, the box has a mass of 40 kilograms. All right. How much force are you pulling on the box with? I love it. How much force are you pulling on the box with? So you're pulling, you're making it move. So this is what we're trying to solve for. Ooh, this is the first time we are not solving for acceleration. I love it. So we're solving for the force that you're pulling with, the force that you are making it move. Now, here's the key. The force that you're pulling it with, because it's moving at a constant velocity, is equal to the force holding it back. The friction force. These are the same thing. They're the same thing. So therefore, if I want to solve for how much force I'm applying to move it, I just need to know what the friction force is. They're balanced. So if I can solve for the friction force, because this acceleration is 0. It's not accelerating. So solve for the friction. And that's it. That's all we have to do in this. Horizontal surface. So Fn is equal to Fw times coefficient. So the force of friction is equal to 40 times 9.8 times 0.6. And that's going to give me my friction force. And the force that I'm pulling it with, because those two have got to be equal. And that's the answer to the problem. As a matter of fact, so let's crank this out. But I couldn't have gotten that if I didn't understand the concept, the important concept of constant velocity, no acceleration. I have to know that that means forces are equal and opposite. Okay, times 0.6. So we get 235.2. I'll split it as 235. 235 newtons. That's my answer. That's the friction. That's the force that I'm pulling it with. They're equal to each other. All right. Well, it wouldn't move if that were the case. It wouldn't move. If it's already moving and you balance the forces, it'll keep moving, just like your car in cruise control. You get it going up to the speed you want. Once you got it going, you just have to balance the friction with the engine, and you move at a constant velocity. So yeah, we can do that. All right. Okay, problem 5. Moving along. Problem 5. You push on a box on a table the force of 300 newtons. Again, box on table. Gotta love them. Gotta love them. All right, let's see. I'm gonna push on 300 newtons. Okay. Your friend helps you to apply 200 newtons. Thank you, friend. You're my friend. Thank you. Wilma is pushing against you and your friend. Ooh, Wilma, not liking this. Okay, with 250 newtons. So that's about 250 newtons, Wilma. Okay, the coefficient of friction is 0.4. Okay. The box has a mass of 60. What is the acceleration of the box? So the box, 60 kilograms. So we're back to finding the acceleration. Okay, all right. Oh, I know, right? We're just going to take these two and put those in the making, because 300 and 200 does beat 250. That's 500 versus 250. 500 wins. So this is going to make it move. And this is going to hold it back. Yeah, just subtract those and divide by 60. You're good. We're good. We've done this kind of a problem before. No, wrong. Wrong. There's friction. Who does friction always help? Friction always helps the loser. Okay? L for love. Dodgeball, 2005 Dodgeball. Great movie, very quotable movie. Watch it. So this is going to be helping Wilma. Wilma is going to get help because she's the loser here, and the friction always helps the loser. So we need to figure out how much help Wilma's getting. So let's figure out the force of friction. Force of friction is Fn times mu. The force of friction is, now this is a horizontal table once again, so Fn is Fw. So this is mg times mu. The force of friction is 60 times 9.8 times 0.4. Okay, multiply those out and let's get how much help Wilma is getting. So 60 times 9.8 times 0.4. Wilma's helping with 200, Wilma's getting help from friction with 235.2. I'm just going to make it 235. All right? Friction is 235, and that opposes the direction of motion. So Wilma is getting a lot of help here. In fact, Wilma almost gets so much help that she almost stops you and I. Okay, this is you and I working. They almost stop because check it out. This 500, and that's 485. So they almost balanced us out. Okay, let's do the problem. So making it move, but we're still winning. So it will move to the right. So 500 minus 485 equals 60 times A. Let's solve for A. All right, I hope you're getting a little practice with these and you're feeling comfortable. If you're not, just keep watching the video again, go back, do it again until you feel like you got it. And I hope you are feeling like you're getting it. This acceleration is 0.25 meters per second squared. But you know what happens in physics, and what happens with me, and what happens in physics, is that once you get comfortable doing something, we move on to something that's a little more difficult. And you go, sorry, it's the nature of life. All right, so there's the answer for that problem. Okay, we're good. The acceleration is 0.25. All right, moving on. Let's keep going. Problem 6. Okay. A box accelerates at a rate of 4 meters per second squared. You push with 100. The mass is the force of friction. Oh, okay. Okay. So box on table. Box has a mass of 20. Box accelerates. We're given the acceleration this time. Okay, we're given the acceleration. So we're going to have to find something else. What's the force of friction is what we're trying to find. So friction always holds you back. So holding it back, find the force that holds you back, friction. We're trying to find F back. That's what we're trying to find here. We're given the mass is 20. We're given the acceleration is 4. Okay. Just plugging into our very important equation up here. This is F is equal to ma. This is Newton's second law, and we're just using it. So let's see. We have to know how much force I'm pushing with. We can't have two variables. It'd be bad. You push with a force. So you push, make it move with a force of 100. And there's my setup. All right. Relatively easy algebra here. We're trying to figure out the force. Now, does it want the coefficient? We could do that. We could figure out the coefficient of friction here. Okay, well, no, it doesn't. It wants the force of friction. Let's do that. So this is 100. Okay, so add x to this side. And then, so I'm going to get rid of x, so plus x is 80 plus x. And now we have 100. So that's 100 equals 80 plus x. Subtract 80 from both sides, and we get x is equal, we need a calculator for that one, x is equal to 20. X would equal to 20 newtons. So the force of friction is 20 newtons. Now, we could figure out the coefficient. Yes, we can. It doesn't ask for it. Let's move on. No, let's figure it out. Because FF is equal to Fn times mu, horizontal, FF equals FW times mu. We now know the force of friction is 20. We know weight is going to be 20 times 9.8. Remember, mg. 20 times 9.8 is 196 times mu. So 20 divided by 196 will give me the coefficient of friction. So I could have asked that, and we could have figured it out. I would have put that at a level 3 problem. It's level 2, but a level 3 would have been that one extra step. Figure out mu. Could have done it. 20 divided, it's like 20 divided by 200, so it's about 0.1. It'd be a friction of about 0.1. Coefficient of friction about 0.1. All right, last problem. Problem 7. Oh, probably shouldn't have erased my box on table. It'll probably come back again. You pull a 50-kilogram box. These boxes on table, man. They're everywhere. They're everywhere. You pull a 50-kilogram box. Okay, with 800 newtons of force. The box accelerates at a rate of 12. Oh, this one does want to find the coefficient of friction. We're going to do this one basically the same way we did the last one, except we have different numbers. Let's do it. This one wants a coefficient. This one says, what is that? All right, here's my working equation. Let's plug stuff in. What's the force making it move? 800. Force holding it back. That's friction. But let's do it this way. Force of friction, this is force of friction holding it back, is equal to Fn times mu. Remember, Ff is equal to Fn times mu. Now Fn on a horizontal surface is mg, it's weight. So we'll make that substitution in right now. mg mu equals mass times acceleration. So the mass is 50. Acceleration is 12. Okay, we want to figure out the coefficient. That's what we're trying to solve for. So, I mean, you can do it the way we did it in the last problem. Go back and watch how I did that. I solved for the force of friction first, and then set that down and put Fn times mu, and then solve for mu. Or you can just do it all at once. You can do it now if you want to. I'm going to do it all at once, because last time I didn't do it all at once. So this is mass 50, so I'll put 50 in here, times g, which is 9.8. There we go. Solve for this mu. Now some of you might say, oh, the 50s cancel. They're on both sides of the equation. No, no, they don't, because you don't have a 50 here. If a 50 was here, all three parts, yes, it would cancel. It doesn't cancel, so don't cancel it. All right, let me get rid of this. Let's solve our equation. It's going to be 800 minus 50 times 9.8 is 490 mu, which equals 50 times 12, which is 600. See if we can do this without a calculator. So 800 is equal to 600 plus 490 mu. Okay. 800 minus 600 is 200 is equal to 490 mu. Mu is equal to 200 divided by 490, which is going to be just about 0.4. Just around 0.4, but let's get an exact number on that. 200 divided by 490 is 0.41. 0.41. 0.41 is our coefficient of friction. All right, that ends up this video. We've done multiple problems with coefficients of friction on horizontal surfaces. But you know what's coming, don't you? Yeah. Non-parallel forces and inclines.